The previous talks have been focusing very much on handwriting and paleography, and now we are going more to the textual contents and trying to decipher whether the linguistic style and how the text is written can tell us something about who the writer is in addition to the paleography. So is my slides are not going forward. Okay. So the structure of the presentation today is that I will give a very, very short introduction to the Papyri grammar project, because it has something to do with today's topic as well. But the project did end in August, so now it's basically done. Of course, it's not done, but the funding is over. But then the main topic of today will be the sort of NLP, natural language processing approach, word vector model approach to our project's data, especially concerning the author and writer attribution or profiling or classification, whatever you want to call it. So in that, I'll shortly explain it and tell what the test data is, and then give some samples and plots for you to see what we ended up with in this preliminary experimentation. So first about the Papyri project, we have done sort of digital online grammar, where we have 3 basic levels. We have the phonology of the Greek Documentary Papyri based on the orthographic variation, and that's heavily relies on the editorial regularizations in the Duke Data Bank of Documentary Papyri. Then we have the morphological level, where we have the whole Duke Data Bank automatically annotated morphologically using AI-based BERT language model. And then the syntactic part is a much smaller collection of texts, the Papyri tree banks, and that data is available openly to everyone for reusing as well. So basically we have a portal online, papygreek.com, where we will have the grammar. It's only partially ready, so it's not published, the grammar part. It will be published whenever we have it in good enough shape for sharing, and there we will have the sort of grammar analysis and explanations, and then links to the queries to the data that we have there. But there will be the search tool is there already, which combines all these 3 levels. So you can do only orthographic search, or you can do morphological search, or you can combine all these 3 parts. But this is so this was just a short snippet of that. But the methods we used in this project basically very in a nutshell. So we used as our source data the papyri.info, Duke Data Bank of Documentary Papyri, and their TEI XML digital editions. We pre-process them for annotation and other kinds of things. We have constant updating system and notifications of changes in papyri.info, when we can then see if we need to also adjust something in our data. We use the existing metadata for date and provenance from the IDP data. Then the pre-processing consists of tokenization, indexing, lemmatization. And for the editorial regularizations, we have sort of the original and regularized text versions, both available. So the variation comes when we compare these 2. So we can also search the variation. It's, as I mentioned, big part in the phonology part, but also there's morphological variation and some other types of variation coming from that. And then we have the tree banking, where we are adding linguistic annotation to the data, and especially important for the syntax. So we have, for example, one sentence here, tree banked. So we have the syntactic relations there, and the XML document contains this data. So we have the part of speech tag, post tag with the morphological code. We have the syntactic role of the word in the sentence. We have the governing word for each word in the sentence. So we can also search for word order issues and that types of thing. So, but more importantly for today's topic, we have added some metadata manually for the documents we have tree banked, and for some other documents as well. We're adding the text type, and then we are giving Papyri person ID numbers to authors, writers, addressees, and external scribal officials. For one document, it looks like this. We have here, I don't know if you see my mouse moving now. There, so it's a sale. The texts are divided by the handwriting. So for each handwriting we add this information. The writer is the person who actually wrote down the text in the papyrus. So we give IDs to this person even though they are anonymous usually. If we have some information in editions or elsewhere about the handwriting, we add the information here. So this is, for example, from my PhD, this document. So I identified there was one particular hand that wrote several documents of this author Hermias, the notary Hermias, who could be the same person who was the author that wrote it. But basically, we know that in many documents, the same handwriting was performing the writing, but in some other documents where author was also Hermias, the handwriting was different. So this is why we can give the ID number here, and basically these are based on editorial and other researchers' comments. Paniskos here is just the external scribal official, but the author is here the notary, the Hermias, and he is identified by his name and as the author because he was the notary who actually signed the contract with his name. Paniskos was just the overseeing official there. So this, of course, looks different for each document, but basically these ID numbers are important for the rest of the talk. So let's go to the attribution and profiling experiments, looking at authors and writers. And this is all work done in collaboration with Erik Henriksson, who was in my team, the programming expert. So if you have any technical questions, I probably will not be able to answer them, but Erik would be a better person to direct those questions to. But I will try to go through with some of these issues here as well. And today was a happy day because we just heard good funding news that Erik will also be for the next 4 years able to focus on papyrus texts. So they got a grant from a foundation in Finland. So let's go and see a little bit about the profiling and attribution tasks. These are named separately here. So we have the profiling tasks exploring how well texts associated with certain authors or writers cluster together based on vector representations of the documents. And we will see soon more about this vectorization. But we are basically dealing with the text with the language and not handwriting. And then we have the attribution task, trying to identify the authors using the machine learning classifier trained with the vector representations. And we are just looking what kind of features, textual features work best here. Are there stylistic feature, words, characters, variation, something else? The profiling task is something where I did a bit more. And the attribution task, I only have one slide with 2 figures for you today. So about vectorization, the machine learning algorithms can't really deal with the text as such, and each document needs to be transformed into a sort of numerical representation of the text, a feature vector. And this feature vector is an ordered list of numbers, which is input to the machine learning algorithm. And each element there in the vector is a feature. And we are using these TF-IDF weight fast text vectors, so term frequency, inverse document frequency, sort of weight bag of word vectors. We also tested with plain bag of words, but this TF-IDF seemed to work better. So there they are. They are learned using a neural network and targeting word based on its context. So looking at the neighboring words as well. So basically, there is the assumption on the background that the sort of meaning of a word is inferred by the company it keeps. So how words and vectors are placed next to each other tell us about the linguistic style of the writer or the author. And these vectors are sums of character n-grams. We'll come back to that. So we had a sort of custom ancient Greek fast text model trained on 30 million words. So there's perceived data and more literary data. So quite a lot of literary data, but then also the whole Duke databank of documentary papyri. So the features we were testing are character n-grams, so bigrams, trigrams, etc. So, for example, bigrams are presented here. So, for each for words, you take always sort of sequences of 2 characters, PO, and then OS, and so on and so forth, and also counting the empty spaces between the words. So also the endings and beginnings of words come clear with the bigrams. And with trigrams, you take sections of 3 letters and so on. And then these bigrams are treated as word and vectorized. Or we can do this only just using words, or just taking function words. In all of the authorship attribution studies, function words is one of the most telling feature of a person's individual style. So how a person uses sort of unconsciously small word, not semantically significant words, but sort of empty, in a way, empty semantically words they tell a lot about the author's own individual usage of language. Or we can look at just lemmas or the part of speech tags and their n-grams. We can look at variations from the orthographic point of view. We can also look at the tree banks and so on. So there's lots of possibilities. What I ended up mostly using were the character n-grams, the function words, and variations. There's lots of literature on authorship attribution, also concerning ancient Greek, and this is one of the latest ones by Manusakis and Stamatatos. They tested different types of attribution methods for the ending of Aeschylus' play Seven Against Thebes, because the ending has always been suspicious, and they did. It's a very nice article. I suggest you read it if you're interested in this kind of thing. And then they actually found in their analysis that the character n-grams, and especially quite long n-grams, so 7 grams and 8 grams, were most useful for their material. So our test case with our Papy Greek metadata and authors and writers we marked there. So as I mentioned, they are based on the text themselves, if the authors are named there, and on editorial comments, sort of for the writers, if editor marks that the texts are written by the same hand, or if, for example, with the Papyri documents, there's autopsy. I have, for example, seen the photographs myself and compared the handwriting of writers. But the benefit is that we can give the ID for the anonymous writers as well, since one handwriting can be present in several documents. And so authors usually have a name. The author is, for example, sender of the letter, the protagonist of the contract or petition, the notary who has signed the text, and the actual writers are usually anonymous. They might, of course, be the same, but we don't know that really. And quite often they are not. And then we can mark some authors and writers also as uncertain, and those would be the test cases as well. If the algorithm recognizes some text that we have marked as uncertainly something, if it really goes together with other texts from the same ID. So from our data, we have there texts from several archives, not usually always the whole archive. And this current test study takes authors from whom most tokens are available in our corpus. So I took sort of top 10 authors who have the most tokens preserved in our data, and actually then reduced it to 8. So these ID numbers, and here is the number of tokens preserved from each of these. So we see, for example, Hermias here has lots of more data than the others, but everybody has more than 1,000 tokens. So these two guys come from the Xenon archive. The texts are letters. We have tree banked them. There are different hands there. Editors just mentioned that there are different hands. They have not actually identified any of them to be same or different. So there we don't have much of the writer information, but the author is clear. Then these 3 following come from the Papyris archive, which was the topic of my PhD, as I mentioned, so the documents are familiar to me. They are notarial, sale and loan and renunciation contracts, mostly not tree-banked. But we have several documents written by same hand, and there are lots of very, very similar hands, as the notaries were a close community, one family or a couple of families, and they learned from each other. So as we were talking already this morning, how to actually identify one person is very difficult, and where is the threshold. So this is the same case with these documents. And then the two last peoples there are from the Katokhoi archive, petitions, letters, and other documents. So there's quite different types of texts compared to each other. And there, the handwriting identification comes from Ulrich Wilken, who published these texts together. You all, yesterday in Jean-Luc Fournet's presentation, you saw the image of Ulrich Wilken. So he already identified the hand of Ptolemaios, who we have here also as an author, but also he wrote some texts himself. And then his brother Apollonius wrote more text, but he is not an author in many of the texts. He has been writing many of the texts. And then we have several sort of more professional scribal hands. But here we are relying only on Ulrich Wilken's opinion. I have not seen many of the photos. I have not myself been able to look at the handwriting. Also with the Papyris archives, I must say that for some of the text, I have not seen a photo or the papyrus myself, because they are not available anywhere. The situation may have changed in 10 years, that there might be more photos available nowadays, but I tried to find a photo or go and see the papyrus myself for as many as I could of the text, but it wasn't possible for all of them. So this is what we then get when we go to the clustering of these texts from these 8 authors by using the feature of character engrams. And I have sort of the from 2 to 5 engrams in one go. And here you see the color is representing each ID. The symbol of in this cluster, the algorithm, I did not give pre-ordered that give me 4 clusters or 5 clusters. The algorithm decided by itself how many clusters it made. So its different symbol represents one cluster. So these belong to the same cluster that are represented with this same form. What is this in English? I don't know, square, which is sort of tilted. So each document is represented by one symbol here. So we see, okay, here's one set of documents that are clustering together. Here's another, and there's more clustering here and there and there. What are these documents then? How do we get? We see that the colors are mixing here, so there are several authors in this cluster, for example. But in this cluster, we have only 2 different colors and so on. So here, this cluster consists of loan documents from the Papyris archives. And this cluster comes from the renunciation cancellation documents from Papyris archives. And these here come from the sales documents from Papyris. Okay, nice. This very tight cluster here is the 2 authors from Xenon archive. And here, this a bit more spread out cluster, or actually the forms are different. So there are sort of different clusters. They come from the Katokhoe archive. Well, that's already quite nice. But is it clustering the text by the text type, or just the is the author relevant there at all?
Maria, excuse me to interrupt you. Could we probably switch to conclusions so we have also some time for a short question?
Okay.
Thanks.
So I was talking, yeah. Okay, I'll try to go quickly through these. So then I added a function word. It looks a bit different. Then I added function words and variation, and we have a sort of a bit different clusters, but here we see again these were the Katokhoe archive texts. Here we have more spread out cluster, and these are all actually coming from one writer from Hermia's hand, or where Hermia's hand is marked as uncertain. And here we have also Papyris texts, and down here was the Xenon archive. So for this Papyris text, we can see the close-up from it, and here we actually don't see the writer 214 many times. It is there, but only 6 times, and also as uncertain in some of the times. And then actually there is no certainty really about the handwriting. For Xenon archive, so we could see it's quite clear cut, the difference between the 2 authors. So it's clearly that this one author is here and the other author is here, even though the clustering symbols are not the same for all. And in this 3D plot, you can see it a bit more clearly how these are separate here, and the orange ones are more tightly clustering from this one author. So the attribution task wasn't as good as the clustering, I think. There's still more work to be done, especially, I mean, the authors is a bit better. There's some mixing here, but for the writers, it gets something really wrong because we don't get everybody here in nicely one line. So the preliminary conclusions from this are that for the profiling task, documents do tend to cluster according to the text type very well. But when we add the features of function words and variation, so we do give actually some information about the writers as well. So that was, I think, really promising. For the attribution tasks, we actually used the character 7 grams for those, and they work best, but they still got really wrong conclusions sometimes. So I would say that the character n-grams worked best, occasionally in smaller, occasionally in higher number. And there's actually, then if this is the case really, then there is no need for linguistically annotated data for this authorship attribution, only identifying tagging authors for the sake of training data. And then function words and variation do enhance the n-grams a bit, but they do not work on their own. So that's perhaps because of there's too small number of data. So always we have the question that if we would have more data, we would get better and more reliable probabilities and results. So that was it. Thank you very much.